Look at these precarious stacks of yellowed paper. For decades, this physical weight, tens of thousands of pages of regulations, contracts, and compliance manuals, has represented the reality of enterprise policy. To turn those dense regulations into working software, businesses relied on armies of analysts and developers. They had to sit down, read through every single line, and manually interpret that logic into code. Legacy rules engines like Drools and DMN were built specifically for this workflow. They gave human minds a structured way to organize and express all that complex business logic, so legacy systems could process it. But because every single rule had to pass through a human brain before it could become software, our own cognitive capacity became the absolute speed limit of enterprise agility. Large language models have collapsed that translation timeline. They ingest, analyze, and translate those massive enterprise documents in seconds, which raises an obvious question. If an AI is already capable of generating existing languages like Python, Java, or Drools, why do we need to invent an entirely new rules language? The answer comes down to who is doing the writing. A human developer needs a target language that is flexible and expressive. An automated AI policy compiler requires a target that is rigid and predictable. Solving enterprise automation in the AI era means we have to stop trying to write better code and instead change the exact target the AI is aiming at. In an AI-driven pipeline, the executable rules are no longer where the software process begins. They are simply the final, compiled output. The actual source documents, these physical contracts, compliance standards, and published government regulations, must be treated as the ultimate system of record. Traditional programming languages are packed with flexible, procedural options designed to help humans express their ideas. An AI compiler doesn't need flexibility. It requires total predictability, strict determinism, and exact recoverability. Every time a language offers multiple ways to solve a single problem, it exponentially increases the search space the AI has to navigate. That expanded search space is exactly where logic errors and hallucinations happen. Forcing an AI to write code optimized for human developers forces it to solve the wrong architectural problem entirely. This is why business decision language, or BDL, exists. It functions as an intermediate representation, a language engineered specifically to be compiled by AI rather than typed by human developers. This diagram shows the exact mechanics of that new compilation pipeline. We start with the source document, run AI analysis to extract specific requirements, compile those into BDL, and generate the final executable policy. Right here at the compilation node, BDL strips away procedural ambiguity. It deliberately narrows the logical search space down to a single straight path, guaranteeing reliable compilation. By restricting the options, BDL acts as the critical bridge, locking human-readable intent into machine-executable certainty. In the enterprise world, automated decisions never exist in a vacuum. They are dictated by specific legal requirements. BDL takes that relationship and makes it a structural reality. This tracing model shows how BDL links a final automated outcome backwards to the specific source paragraph that mandated it. Because this connection is built in, the system automatically captures eligibility, reason codes, and derived facts without extra tracking logic. Explainability is an inherent property of the execution model, removing the need for separate auditing layers or manual decision logs added after the fact. To see why this matters, imagine a government agency suddenly publishes a massive amendment to an existing compliance standard. In the past, engineering teams would scramble through millions of lines of custom code trying to find exactly what broke. The BDL compiler simply calculates which specific requirements changed in the source text. Once it identifies those changes, the system automatically regenerates, deterministically runs the tests, and redeploys only the affected parts. As AI assumes the heavy lifting of software generation, the most critical programming languages won't be the ones that are the easiest for humans to type. They will be the ones that preserve intent and provenance from a living document all the way to a runtime decision. BDL serves as the definitive policy compilation target, built specifically for the AI era, rather than a replacement for traditional coding.